Hello everyone. In this video, I'm going to solve one of the most popular lead code problem, that is 2sum. So without any delay, let's get into the problem. So here, given an array of integer nums and an integer target, return indices of two numbers such that they add up to target. So what the question they gave us is, they gave us nums, which is nothing but it's an array of integers, okay, and also they gave us a target, okay. Now they want us to return the indices of two numbers, okay. They want us to return the indices of two numbers. What are those two numbers? Those two numbers have to be something such that they add up to target. So whatever the indices that we are returning, right, the corresponding values in that nums should add up, and that addition value should equal to the target. So when you see the example one, right, nums here we got 2, 7, 11 and 15, right, and what the target that they gave us is 9, okay. Now here, when will or how will we get 9? It's nothing but if we add 2 and 7, right, 2 plus 7 is equal to 9. So now what we need to return? The indices of those two numbers. So then what's the corresponding index of 2, which is 0, and the corresponding index of 7, that is 1. So here we are returning an output of array which is with the indices values like 0 and 1, okay, clear. So now we will start solving. So how we can be able to solve this particular solution, okay, 2sum, right. So here they gave us nums, right, nums, and 2, 7, some 11, some 15, okay, and the target they gave us is equal to 9, right, as based on the example 1 that they gave. So what are all possible like solutions that we can think of? So think in such a way that, so what we need to do is like we need to return the indices, right, indices, and these indices is of for two numbers, right, two numbers. This was fixed, clear. So how will we be able to get? So one of the possible solution, or let's say a solution one, a pattern or something, let's say a brute force approach, right, mostly in this DSA we used to call this as brute force. First one, whatever the simplest solution irrespective of whether the time how much it consumed or whether the how much space it consumed. So whatever the thought or whatever the solution that we create, that comes to a brute force, right. So like whatever the brute force solution that I am thinking of is like, so whatever the nums that we got, right, that is 2, 7, 11 and 15, if I iterate for every value, I need to check whether the other values sum up and will return the target or not, clear. Here we observe that, okay, 2 and 7 are like beside to each other, it will be like quick. But how about in a scenario where let's say there is 1, 2, there is 11 and there is 7, okay, in this scenario, so we need to check every possible thing. We don't know where our solution relies on, right, where our solution is. So in that solution, in that, like in that way, so how we can solve this one? So for every number, I'm checking whether there is any solution that any target, so any value of target that I will get with the other numbers. So here with the one I can check, uh, so I will start with the value 1, and I will check the next number, which is nothing but 2. So 1 plus 2, nothing but 3. Will that equal to target? No, right? Then I will check 1 with 11. Will that be equal to target? No. Then I will check 1 with 7. Will that be equal to target? No. Then I will move to the another number. So which is nothing but 2. So again, with 2 to 11, 2 to 7, there we will get the solution, right? 2 and 7. Or else we can go like the third number also, 3 and 7, 11 and 7, right? So these are all possible solutions that we can find, and out of those solutions we will get whatever the target that we are looking for, right? This is one of the brute force solution that I'm thinking of. So here how we can be able to write a solution. So this should be consists of two for loops, right? One for loop starting taking care of like individual values, where the other for loop, inner for loop, taking care of like iterating through the other elements. Okay, for let's say int I is equal to 0 and I less than some nums dot length, let's say I call it as an n, and I plus plus. And also in the inner for loop I will take from where I should take from, should I take from 0 or should I take from I plus 1? It's I plus 1, right? For I is equal to j, I should take from I plus 1. Why is because, so in the question itself they mention like you may assume that each input should have exactly one solution and you may not use the same element twice. So if I use the value 0 from here, that means I'm using the same element twice, right? In a scenario where there is 3 2 1 and the target is 6, so if I use I is equal to here in at 3 and j is equal to at 3, 3 plus 3 I will get 6. But should I return? That won't be possible, right? That is not a correct one. So that's why we need to increment the I value from here, from the second value itself. We will iterate till the end and we will check for every possible values whether that is equal to target. So so after this what we are checking? We are checking if nums of I, whatever the value that is corresponding to the I in nums along with nums of j, if both are equal to the target, right? Then what should I do? I need to return I and j, right? I and j are nothing but our indices, right? So here I need to return a new integer array with a I comma j, right? So this is one of a brute force solution I was thinking of. So here why I am saying brute force is because, so what is the time complexity here? What is the time complexity? Time complexity based on this solution we can say it's like order of n square. Why order of n square? Because for every value we are iterating till the end, right? So there is one outer for loop which is taking care of every individual element till the last, till the end, and also there is an inner for loop which is iterating the other elements till the end also, n. So it will go for I, it will go till n, and for j it will go till n. So nothing but n into an n square. N square is the time complexity, whereas the space complexity is nothing but like we didn't use any kind of additional spaces or additional any data structures or something, right, for to store some values. So that's the reason it's like order of 1 is the space complexity. Clear? This is one of the brute force part, one of the solution that I am thinking of. So and let's go to the pattern 2 or second, another solution, another form, where how about, so our nums, let's say nums is equal to 2, 7, some 11 and 15. Okay, and the target is 9, right? Now how about if we go to, do you guys think of anything? Yes, one of the possible solution that we can think of is like, how about if we sort? This seems sorted, right? But when you observe here 3 to 4, right, this isn't sort, right? So in that scenario, how about if we sort the values 2, 7, 11 and 15? Now after this sorting, what we need to do, we need to find, we need to search, right? Search the element that is equal to the target. So searching, when we think of searching, what are the two things that we think of? There will be a linear search and there will be a binary search, right? So compared to linear, if it is sorted, we will obviously go prefer to go with the binary search, right? So if we go to the binary search, then like we will take a left pointer and a right pointer and we will find the mid. Then based on that, we will uh, think like based on the mid value, and if it is greater or less, we will take the one half of the array out, leaving the other half behind, right? We will search in the other half. So in this case, this is one of the scenario we can think of, and this is quite good compared to the above time complexity. So why? Because it's like here, what could be the time complexity if we think of? Time complexity could be, for sorting, the it will take like order of n log n time complexity, and after sorting we are doing searching, right? That too, it is a binary search, so it's like order of log n, which sum up we generalize it to call like order of n log n, right? This is the time complexity that we are taking care here. This order of, observe, this order of n log n is quite good compared to order of n square, right? So that's why this form is quite good compared to the brute force or the first form which we solve. Okay, and do we think, is this the only optimized solution? There will be another, right? There will be a few more. If we think of, there will be another optimized solution that we can consider, that is with map. Cool. If we consider map, okay, if we consider if we take map, how it goes, like map is nothing but like a data structure which stores a key and a value, right? It stores a key value pair. Now here, so observe 2, 7, 11, 15, right? In these values, first I will go here, I will see that target is equal to 9, right? Here when you guys observe, if I found one, okay, if I consider first element, if I subtract this particular element with that particular element, and we will get the other element, right? Nothing but 7. Clear? So for that reason, how about at every stage, if I will check in this map, I will store this particular key as this particular value, nothing but 2 here, and the value should be the index of that particular element in the array, nothing but 0. So I will store here in the map. Now second time when I get into the another element, I will check if target minus this particular element, right? target minus if this nums of I is equal to whatever the value that we get, right, that is present in the map or not. Okay, if it is present, then I can return this particular value and also this particular I, right? Clear? So in the map here, so initially I don't have any, so I can add directly the first value, right, 2 comma 0, right, like here. Now when target is equal to 9 and the next element that I'm going to ask, let's say in next element, okay, next element or second element or whatever the variable that we call, so it should be like target minus nums of I, right? So target is nothing but 9, nums of I at this particular point, what's the nums of I? Nothing but 7, which is equal to 2. So we will check if the map contains the value to S. It contains the value to, so now we are returning whatever the get value of this particular value in the map along with this I value. Clear? This is an optimized solution that we can think of. So time complexity, what could be the time complexity? It is order of n, and the space complexity is also order of n. Clear? So we might think here that there is a space complexity of order of 1 which is good compared to order of n, right? But think here, so our major or our first priority would be the time complexity. So if time complexity would be better, even if we compromise the space, that will be good, that will be great, because every time for every algorithm we need this time complexity is one of the major thing that we want our application to be very fast, very quick, right? Not it don't I don't want that to be lag. If some kind of lag is there, no other customer are willing to come and use my product, right? So that's one of the reason where in some scenarios we can compromise the space for making the time better. Clear? So I think we will solve this uh, approach with respect to code. Okay, so what we need to do here, initially we need to create, so I'm sorry, we need to create a map, right? So how we create, it's a map of whatever the values, it should carry integer and integer, right? So let's say I call it as a map, and here which is equal to new hash map. Clear? Now, so after this hash map is created, what we need to do, we need to iterate our values, right? Int I is equal to 0 from very first, and I is less than nums dot length, and it is I plus plus, right? Now here what should we do now? So after creating the map, and we start from the very first element, right? So observe here, I need to check if that element is in the map or not. If map dot, let's say here, contains key, we need to check if this key is present inside the map or not, because whatever the values that we are seeing, that we are storing it in the here, right, as a key, right? So contains key, and what's the value that we need to take care, that should be its target minus nums of I, right? So This is the value that we focus on. And if I found that key, then what I need to return, I can return a new sorry a new integer array, right? A new integer array with whatever the values that I need to do return. I need to return map dot get off. So here I need to get this one only, right? Target minus nums of I value. So how about if I'm making this as a variable here? So int, let's say a value is equal to target minus nums of I, and value here also value, okay, nums of I, and whatever the other value that I need to return, I, right? Clear. If the value, so this is the part which, if the value is there in the map, if it is not, then what should we do? We need to add that value into the map, right? So I need to put the value into the map, whatever the values are, that is nums of I and I, right? And that's it. If there isn't any solution, then what we need to return? We need to return a new integer array of some empty. Clear? Let's run this. Cool, everything is working fine. And if we submit this, cool, this solution beats 99.29% people. Fine, but can we see what are the other solutions, the other people that they solved? It's like two for loops that they consider, starting with 1 and 1. hmm. J and j minus I. Okay, cool. And also stum.gc, it's fine though. hmm. Cool. uh, for int I is equal to 1, I is less than, this is the solution, right? Nums, okay, I plus plus, and j is equal to I, nothing but 1 only here, 1 1. So whatever the nums of 1 plus nums of 1 minus 1, nothing but 0, right? So if both are present, then j minus I and j. Okay, clear. hmm. Cool. And thanks everyone.